In this module, we will look at the different types as well as the various steps that describe the biological process of germination, beginning from water imbibition, enzyme activation, initiation of embryo growth, rupture of seed coat, and seedling emergence. This lesson in particular will cover the two types of germination as well as water imbibition as the first step in seed germination. Seed germination is a biological process that leads to the resumption of the active growth of the embryo that finally results in the rupture of the seed coat and the emergence of a young plant. Very simply, seed germination refers to the emergence of the radicle or the embryonic root through the seed coat. These pictures show observable changes in the overall morphology of lepidium seeds during germination. Panel A shows the rupture or breakage in the seed coat after the mature seed take in water in a process known as water imbibition. The white portion that you see here is the exposed endosperm due to the break in the seed coat. In panel B, we can see here the radicle, and we can see it emerging from the seed. Below are pictures showing observable changes in the overall morphology of tobacco seeds during germination. Again, panel A shows the rupture or breakage in the seed coat following water imbibition by the seed. This white portion that you can see here is the endosperm which became exposed due to the break in the seed coat. Panel B shows the emergence of the radicle or the embryonic root right here from the seed. Depending on what happens to the cotyledons during embryo growth, seed germination can be classified into two types. The first type is epigeal germination, and the second type is known as hypogeal germination. Let us first describe what an epigeal germination is. The word epigeal came from the Greek word epi, meaning upon, and ge, meaning earth. Put these two words together and the word epigeal means upon earth or above ground. What does epigeal germination mean then? In epigeal germination, the cotyledons are raised above the ground where they continue to provide nutritive support to the plumule or the embryonic shoot. During root establishment, the hypocotyl elongates into an arch and breaks through the soil, pulling the cotyledon and the enclosed plumule through the ground and projecting them into the air. The cotyledons open up as the plumule develops. This kind of germination is characteristic of beans and pine seeds. We have in this slide as an example illustrations of epigeal germination in red beans and castor beans and also in onion. Panel A illustrates epigeal germination in beans. We have in the first drawing a bean seed that is still below the soil surface but is already establishing a root system, as you can see here. During this process, you can also see the hypocotyl, which is right here. It's already forming an arch and breaking through the soil. As the hypocotyl breaks through the soil, the cotyledon, with the embryonic shoot inside of it, is flung above ground, as you can see in the second drawing. This same process can be observed in panels B as well as in panel C, where the cotyledon is projected above ground, as you can see here and also here, through the action of the hypocotyl. The projection of the cotyledon above ground during germination is characteristic of an epigeal germination. How does this differ from hypogeal germination? The term hypogeal comes from the Greek word hupo, meaning under, and ge, meaning earth. Put these two words together and the word hypogeal means under earth or underground. During a hypogeal germination, the cotyledons remain underground while the plumule or the embryonic shoot pushes upward and emerges above the ground. The nutritive tissue in the form of endosperm or cotyledon continues to provide nourishment to the growing shoot. Hypogeal germination is characteristic of peas and cereals. In grasses, the coleoptile provides structural support and rigidity to the emerging plumule as it pushes through the soil. We have panels D and E illustrating hypogeal germination in peas and also in corn. You can see in panel E right here a corn seed starting to germinate. As the seed establishes its roots in the second picture here, the shoot also breaks through the soil and it is protected by the coleoptile. The nutritive tissue in the form of endosperm remains underground, as you can see right here. During germination, seeds follow a specific sequence of events starting from imbibition. This is followed by enzyme activation, initiation of embryo growth, rupture of seed coat, and finally the emergence of seedlings. We will now define each of these physiological processes, beginning with imbibition. Germinating seeds take in water in a triphasic pattern. The first phase is characterized by a rapid water uptake by the dry mature seed. This is followed by a leveling off of water intake as the metabolic processes in the seeds are reactivated. As the radicle or embryonic root emerges, water uptake increases ever so slightly. This first phase in triphasic water uptake is also known as the imbibition stage. The word imbibition came from the Latin word imbibire, meaning to drink. In seeds, imbibition is defined as the process of rapid water uptake resulting from the hydration of seed storage polymers. Recall our discussion in seed development and maturation. As the seed matures, it undergoes a controlled process of drying. This drying process is a necessary step to arrest or temporarily stop the metabolic processes in the seeds until such time when the conditions are suitable for germination. Given that the seed is dry, it needs to rehydrate so that it can resume the metabolic processes necessary for the embryo to grow. Imbibition is a physical process. It is not dependent on metabolic activity, but is related to the properties of colloids in the seed tissues. Imbibitional water uptake can generate up to 10 to 20 megapascals. This force is sufficient to break rocks. In this panel below, we can see external changes in soybean seed imbibing or taking in water from 0 to 600 minutes. Notice the increase in the size of the seed, as you can see here, from 0 to 600 minutes of water imbibition. In summary, seed germination is a biological process that begins with water imbibition of a dry seed and ends with the emergence of the radicle. Depending on the fate of the cotyledons, germination can be classified as either epigeal or hypogeal. In epigeal germination, the cotyledons are pushed above ground where they continue to provide nutritive support to the plumule or the embryonic shoot. In contrast, hypogeal germination is characterized by cotyledons remaining underground while the plumule pushes upward and emerges above the ground. Seed germination follows a specific sequence of events, beginning with water imbibition, followed by enzyme activation, initiation of embryo growth, rupture of seed coat, and emergence of seedlings. Seeds take in water in a triphasic pattern. The first phase, which is characterized by a rapid water uptake by the seeds, is known as the imbibition phase. The rapid influx of water into the seeds during imbibition is a result of the hydration of seed storage polymers.